In this lecture of maxima and minima, we will understand the first order derivative test and hence the working rule for finding points of local maxima or points of local minima using the first order derivative test. The first derivative test says that C is a point of local maximum if f dash c is equal to 0 and f dash x changes sign from positive to negative as x increases through c. Now observe this figure. In this figure, we see that at x equal to c, f dash x is changing sign from positive to negative and also f dash c is equal to 0. Therefore, we can say that c is a point of local maximum. Hence, this behavior of f dash x in the neighborhood of this point c will help us to find the local maximum point for a given function in its domain. Also, the first derivative test says that c is a point of local minimum if f dash c is equal to 0 and f dash x changes sign from negative to positive as x increases through c. Now observe this figure. Here we can see that at x is equal to c, f dash x is changing sign from negative to positive and also f dash c is equal to 0. And hence we call x equal to c is a point of local minima. Therefore, this behavior of f dash x in the neighborhood of the local minima point will help us to find the local minima points for a given function in its domain. So, this method is called the first derivative test. By this first derivative test, we can find out or locate the points of local maxima or local minima. Therefore, we will see the working rule to find the local maxima or local minima points. The first step is find f dash x, that is, find the first derivative of the given function. Then step 2, solve f dash x is equal to 0 and let these values of x be a, b, c, etc. These are the candidates for maxima or minima. Step 3, test the function for each one of these values. Say x is equal to c. Step 4, determine the sign of f dash x for values of x slightly less than c and for values of x slightly greater than c. Hence, we can conclude the following. First conclusion is, if f dash x changes sign from positive to negative, the function is maximum for x is equal to c. Conclusion 2, if f dash x changes sign from negative to positive, the function is minimum for x is equal to c. And conclusion 3 is, if f dash x does not change its sign, then x equal to c gives a point of inflection. In fact, it is neither a point of maximum nor a point of minimum. It is called a point of inflection. Therefore, we will summarize the working rule in the following table. If f dash x has a positive sign in the left neighborhood of c, that is when x is slightly less than c, and f dash x has a negative sign when x is slightly greater than c, then we say that x equal to c is a point of local maxima. Or if f dash x has a negative sign in the left neighborhood of c, that is when x is slightly less than c, and f dash x has a positive sign when x is slightly greater than c, then we say that x equal to c is a point of local minima. However, if f dash x does not change the sign, that is, if it remains positive on both sides of x is equal to c, or it remains negative on both sides of x equal to c, then x equal to c is neither a point of maxima nor a point of minima. And then in that case we call x equal to c a point of inflection. Hence, we can find out the points of local maxima or a local minima using this first derivative test.